So our question is, an electron falls from rest through a vertical distance h in a uniform and vertically upward directed electric field E. So the direction of electric field is now reversed, keeping its magnitude the same. A proton is allowed to fall from rest in it through the same vertical distance h. The time of fall of electron in comparison to time of fall of proton is. So the electron is falling from rest. So its initial velocity will be 0, and vertical distance to be covered is h. Elect Electric field magnitude is E, and it is directed upwards. Since the electron is negatively charged, it will experience the force downwards. So now electric force is equal to Q E. This is our electric force. So again it will be equal to E. This is our electric force. So now, using Newton's second law, we will find the value of MEA equal to ET. We will find the value of A from here. So our A will be A equal to E M E. Now using second equation of motion, we get H equal to UT plus AT square by 2. So our initial velocity was 0. So we will get H equal to just AT square by 2. So we will put the value of A in this equation. From this equation, we will put the value of A in this one. So we will get, after putting the A value, H equal to E T square upon 2 M E. So now we will also find another value, that will be finding time. So how we will find time? We will find by T equal to root 2 M E H upon E. So this will be our, let us say, first equation. So now proton takes the place of neutron, and mass of proton is greater than mass of electron, but the magnitude of charge is same. So from equation 1, it is clear that T is proportional to root M. So the time taken by proton will be greater than time taken by electron. So our correct answer is this one, smaller. So answer 3. Thank you.